Hi everyone! Today we're going to talk about JWT, JSON Web Tokens. We're going to cover what are they good for, what's the concept behind them, and we're going to use them with a small example application. Now this small example application is built on a Node and Express backend and an Angular frontend. However, the Angular frontend is not going to be center of this tutorial, but we will focus rather on the backend with Express. So let's get started. Okay, so JWT, JSON Web Tokens. At first we want to know which goal do they accomplish. We want to know the why JSON Web Tokens. They serve the purpose of authentication, meaning you want to verify if a user is the user he or she claims to be. So if a client makes a request, we want to authorize it. We want to see if the client has access to that route or to that endpoint or to that resource. Now, JWTs are not for initial authorization, so if you log in with your username and password, that's not done with JWT. JWTs are rather comparable to sessions, meaning once you've logged in, just username and password, then JWTs come to play, because on a subsequent request, then this authorization can be handled with JWTs. And this is what makes them comparable to sessions, because traditionally this concept of authorizing subsequent requests is handled with sessions, and so JWTs can be seen as an alternative to sessions. Now, how does this authorization exactly work? On the first login of a user, we check regularly if the password is correct, meaning we just apply our hash function, check if the entered password and the hash passwords are correct. No JWT involved in this. But then if the passwords are matching, then what's happening is that we generate a token, because JWT is for JSON Web Token, so we want to generate a token. What does it mean? It means we call a function, a signing function, which is a fancy word for cryptographically generating a token. And this signing function has two inputs. It, for one, takes some JSON data, which is usually the user name, for example, or the user, let's say, email address. And we take, as a second argument, we take a secret key, and we put those two together, so that the data plus the key, the secret, and this JWT sign function then generates a token. So JSON data, you can think of this as the user JSON, plus a secret string generates a token, which is again a string. And this token is then added to the request, and it's sent to the front end. And the front end, the client, it stores the token, for example, in local storage or in a cookie. So it can attach it on a subsequent request. So in the header of a subsequent request, the client attaches the token. And then the server uses the JWT verify function. And the JWT verify function, it's kind of the inverse of the signing function. It takes the token and the string, and it then decodes it into this initial JSON input data. So what we have here is that signing is taking JSON, taking secret, producing token, and verifying is taking token, taking secret, and returning the authorization data. And if this token, of course, is just some random string, nothing will be produced. Okay, so let's get started. We will start with a simple setup. It's just mostly a regular Express application. You see here we import Express, and we have also some other imports. First of all, we have JWT, which we're not gonna use for this step of the tutorial, but later on, but we're already importing it now, so we have that set up. Then we need CORS. CORS stands for Cross-Origin Resource Sharing, and we'll need this because our front end will be running on a different domain, or more specifically at a different port, so we need to be able to share resources between front end and back end, and that's why we need to import this CORS here. And last but not least, we will make some post requests that have a body, meaning a JSON object, the payload, and Express by itself is not capable to parse those, so we need to import the body parser. Here it's pretty much a regular Express setup. We create a new app. We apply the CORS package so that we actually can use the cross-origin resource sharing, and we apply the body parser, and we set up a first route at /API, which just returns a JSON with a message saying welcome to the API. And then we listen to port 5000. And I've started a server here, can do it again. So we are just starting a server at port 5000. And you see here our API. It's just saying welcome to the API, so pretty much a regular setup for now. So in step 2, we'll get actually to work with JWT. What I'll do is I'll check the difference to the first step so we can see exactly what happened. I did this with git diff in IntelliJ, so it's nicely highlighted here. So all of this code here is new, and what's happening here? I have some hard-coded users. I have Max at Gmail and Lily at Gmail, and they have an email, a name, and a password. And of course you shouldn't store the password like this, but of course you would also not have users that are hard-coded like this. So, and I also have something related to JWT here finally. And namely, we have this secret we have seen before in the conceptual overview. And it's just some secret of some length. It's just a string. And then let's skip this for now. It's some middleware, but it's not actually this important for the concept. And what we'll see here is in this API login route, it's a post. So this is what should happen if a user tries to log in. So if user tries to log in, the user provides password and an email address. And we see that if there is an email address and there's a password and the user from the database, which I get from here by just putting into this map the email. So for example, if I put in Max at Gmail, here I retrieve this JSON object. So I see if those users' passwords match, then I'll get into this block. Otherwise, I'll just say permission denied. And this step didn't have to do anything with JWT. This was just plain old authentication of a user, just comparing passwords. But now comes something that's related to JWT. And the first thing here is this JWT sign function. And this JWT sign function takes two inputs. For one, it takes this secret we have defined above, and it also takes a user or some JSON, in fact. So some JSON plus a secret is cryptographically mingled into a token. So this JWT sign function returns a string which is a token, and which we'll see later on, which we can decrypt again. So this is the encryption step. Now this encrypted token, we're sending it to the front end, and the front end then can store it. So it can actually do something with it later on. And let's check quickly what the front end's doing. So the front end is a small Angular application. We're seeing this here. And we have this authentication service, for example. And what we see is if we issue a login, so then we do this post request that we've seen in the backend, how it was implemented. And if it's a success, we say, okay, now we are logged in. And we also save the token from the request. And saving the token just means we are putting it to the local storage of window. And then what will happen is that there will be like a message, hey, you're logged in now. And if I provided the wrong password, it will just say, oh, an error has occurred. And let's quickly check how this will look like. So this is the JWT front end. If I enter a wrong password, I get, oops, permission denied. And if I enter the right password, I get through with it. Now this login didn't have to do too much with JWT, but if I refresh the page and I'm still logged in, this is the JWT part. Now what we haven't implemented yet is the logout function. You see if okay, it actually works already because I have started something more. But for example, the count balance we haven't implemented yet, and we're going to see that in the next step. Let me quickly check the step 1, step 2. Yeah, the logout worked because it just was purely front-end wise. It just destroyed the token from the local storage, and then it says logged in equals false. And now if the front end doesn't know the token anymore, that's why the logout is already working. But the account balance we're going to see in the next step. Now, in our final step, the third step, we're going to implement this getAccountBalance function. Again, we are doing a git diff, so we can nicely see what has actually changed in the file. So first we see we have new this JWT middleware. And what does it do? It checks if a request is coming in, we'll get its headers, and more specifically, we'll get the authorization header. And we're storing this into a string, and we're checking, oh, is it actually a string, and does it have a space? And it's kind of a convention in JWT that you have the authorization written to the authorization header, or the token to the authorization header. Somewhat like this, you write token, then a space, and then the actual token, or for example bearer, and then a token, and then the actual token. But it's always like some identifier, then space, and then the actual token. So that's why we are interested in splitting this authorization string by the first space we see. And if we split it, then in this array that is returned, the first item will be token, and the second part will be the actual token. So the first array item will be the string token, and the index 1 will be the actual token. And what the middleware then does is we'll call the verify function. And if you recall, the verify function is kind of the opposite of the sign function. So what has been encrypted here is getting decrypted here. So what it takes as an input is a token, and again the secret, and what is coming out of this is the JSON data that has been encrypted here. So what we'll get back is this user without password in this case. And we see if there was an error for some unknown reason, we'll just return a 4.3. But otherwise, we'll store the decoded user without the password into the request. So we can actually use it on the subsequent request. And then we call the next router function. So if all of this was a bit unclear for you, maybe you didn't understand how the Express middleware works. It's just a function that does something between, so let's say I want to get API balance, and then I want to return a user's balance. But before returning, I want to do like some authentication. And then I can put in Express here this authentication middleware, and if it has done its job, this middleware calls next, and when next is called, it will go into this block. So all in all, if verify is successful, if it didn't have an error, so if JWT worked and it authorized the user, then it will continue, and then we'll go into this block. And we know now that our request has a decoded property, which is our user. And now we can get the balance of a user just with this simple method here. You just see, okay, we have some hard-coded balance values, and the get balance is just, again, getting from this map, accessing it by email and returning the value of it. So we see that we can, we usually should get a balance because otherwise authorization wasn't possible, but just a double check here. And if we get it, then we return balance to the front end. And now if we actually start this, that would be step 3, and it's called balance. Step 3, balance, like this. And we also have the front end running, and we see we are still logged in, and we can get our balance. And I can also log out again and log in maybe as Lily, and she has a different password, and get her balance as well. Now, one thing that's quite interesting is, you see, if I shut down the server, start it again, I am still logged in. And this is because the JWT is a stateless authorization mechanism, at least like this. It's because I only needed the user data plus the secret, which gives unique token. And if I then store this token into the browser local storage, I can shut down the server, I can do whatever I want. If I send this token back to the server and the server knows the secret, it can decrypt the token again, and it will retrieve the exact same user data. And now this also causes kind of a small problem, because, or maybe a large problem, because what are you going to do if you want to invalidate a session? So if one of the users has, let's say, we encrypted Max, and let's say, where's this data? So we encrypted this data, right? Without the password. So we encrypted this. And unless something changes around this, we don't have any possibility to destroy the session of a user. So how are we going to handle invalidation? And well, of course, you can set an expiry date. That's an additional feature of JWT. But if you need for an unexpected reason to invalidate a session, it's not that easy with JWT. And that's why some people recommend to stick with traditional authentication mechanisms like sessions. There's also another video, see the description here. And yeah, another issue with JWT might be its size. The tokens can blow up quite a bit if you store a lot of JSON data into a token, and this token always needs to get sent over the network. But what some people find really cool about the JWTs is that they're essentially stateless, so that I can shut down my server, I can have 5 servers, as long as all the servers have the same secret, they're all able to authenticate my users. So that's pretty much it about the JWTs. I hope you've liked the video, subscribe, and see you next time.